So for circuit 2 we have the diagram like this. That's RL, that's R1, that's R2, that's RE, and we have our battery, which I call the S. And we can add on some voltages and currents. We know that this will be VE, and this will be VB, and that this will be VR1, and this can be VL. And we can also say that there'll be a collector current here, which is IC, and a current that flows in this resistor called I1, and we'll say that there's a current there, and current here which is IB, and this is equal to 0, so this must be IC as well, because IE is equal to IB plus IC, IB is 0, therefore IE equals IC. And of course, we know that that's VS. So we can write out some loop equations as before, and oh, we've missed out VBE, which is there, and we know that it's going to be 0.7. So the first loop we can write out is this one here, which says VB is equal to VE plus VBE, and we can put some currents into that, because we can say, well, if IB is 0, then I1 flows through R1, then the only other place that I1 can head off to is down through I2, so this must be I1 as well. So we have VB is I1 times R2 is equal to IC times RE, which is Ohm's law for that resistor there, plus 0.7 volts, which is our, so this voltage is that voltage plus that voltage, but written in terms of the currents that flow through the resistors. So we'll call that, I think that's called 2 in the notes actually. Yes, it is. And the other loop we can write out is that VS is equal to VB plus VR1 plus VL. So we can say that VS is equal to VB plus VR1 plus VL. And we can do the same sort of thing as we did before. We can say that VS, which is the voltage source, so we can't write that in terms of a current and resistance, but we can certainly do it for VB, and that will be I1 times R2 plus I1 times R1 plus, now the current that flows in RL, current that flows in here must add up to the current that leaves. So we've got a node here, and I1 leaves the node and IC leaves the node. So whatever flows into the node has to add up to these two. So this current here must be I1 plus IC. If you want to, you could give it a name like IL, but I'm not gonna. I'm gonna write that straight in. I1 plus IC times RL. And I think in the notes that I give out, that's called 1. Is that the case? Nearly. It's slightly rearranged to give 1. To give the equation which is 1 in the handout that I give out, you just have to group the terms in IL. So in I1, sorry. So we've got I1 R2 plus R1 plus RL plus IC RL. So that's how it's written out in the handwritten sheets. So the two important equations are, get rid of that because it's just an intermediary step, and get rid of that because that's just an intermediary step. I can get rid of that as well, and that leaves us with these two. So we've got to get rid of I1 somehow, and we're heading towards IC, because IC is what we'll need to know IC to calculate what VC is, the voltage from this node to ground. We may need to know I1 as well, depends how the equations run, but if we do need to know I1, we'll be able to back substitute into an equation that we derive along the way. So you've got options as to how you get rid of I1. You could rearrange equation 2 to get I1 and then substitute the answer for that into equation 1. Or you could rearrange equation 1 for I1 and substitute into equation 2. Or you could attempt to get all the I1s together and eliminate them somehow. I'm going to eliminate I1 from, well, I'm going to substitute actually, but I'll get rid of I1 from equation 1 by rearranging equation 2. So the first thing we need is a rearranged version of 2. So we'll have I1 is equal to IC times RE plus 0.7 divided by R2. That's our rearranged. Then we'll sub that into here. So I'm going to rub out 2 to give myself a bit more space. So we'll do VS is equal to IC times RE plus 0.7 divided by R2 multiplied by all the stuff in the bracket, which is R2 plus R1 plus RL, close the bracket, plus IC times RL. So that's just this bit inserted, so all that stuff goes in there, and that's how you get to that one. So having got to there, the only thing that we've got to do is rearrange that equation to give a value for IC. So we can multiply everything through by R2, I guess, would be one approach. Yeah, we'll do that. So we'll do, because we want to get IC on its own, really. Nah. So we'll do VS R2 is equal to all that lot. IC RE plus, we have to multiply this lot out through as well, don't we? 0.7, so I need a bracket around that now, times R2 plus R1 plus RL plus IC RL. Okay, so then we'll have to separate this out, so we'll do VS R2 is equal to IC RE R2 plus R1 plus RL plus 0.7 brackets R2 plus R1 plus RL plus IC RL, which is really just it's not expanding this bracket, I haven't completely expanded it, but I've put this bit twice, so I've got IC on its own with RE and the 0.7s over here. I've missed a bracket there as well, didn't I? And the IC plus RL dropped on the end. Okay, so then we can collect up the ICs now. We can have VS R2 is equal to IC brackets RE brackets R2 plus R1 plus RL close brackets plus RL close brackets plus 0.7 times R2 plus R1 plus RL. So that bit is now dropped down there. This bit has come up here, and all this stuff here is now there. So we've got IC with a bracket all of its own. So we'll take the 0.7 stuff across, and we'll have the VS R2 minus 0.7 times R2 plus R1 plus RL, close brackets, is equal to IC times all of that stuff there, which I'd really rather not write out again because I can't be bothered. So what I'm going to do is just divide through by this to give me RE R2 plus R1 plus RL plus RL, which is very nearly the form that's given in the handout. When I say the handout, I'm talking about the handwritten handout, or if you're watching this as a repeat on Dave, there should be a typed up one eventually when I've written it out. So to get it into that form, the only thing we've got to do now is divide by R2, I think, possibly. I'm missing an R2 here. How's that happened? Idiot. Look, see, I back up here, I got rid of the R2 by multiplying VS by R2, and I multiplied all this stuff out, which got rid of the R2, and I didn't multiply that by R2. That was extremely naughty. R2, R2, and where did it go off to? It's gone to there, hasn't it? R2, and that needs to have an R2 there as well. Right. That's why I've never asked this as an exam question. It doesn't show anything to say that you can do this. The only thing that's really important is that you know how the loops work and how the node currents have to sum in order to obey Kirchhoff's laws. This stuff is just maths. Great if you're a mathematician, but we're not interested in it really. Other than the fact that you need to be able to do it to actually do the electronics properly. So we can now divide through by R2 quite safely, and we'll end up with IC is equal to VS minus 0.7 times R2 plus R1 plus RL over R2 divided by RE brackets R2 plus R1 plus RL brackets over R2 plus, now the R2, I'm dividing everything by R2, so this will cancel, which is how I knew that I'd missed it, because I knew the next thing to do was divide by R2, and I thought, oh, I can't, because I'd messed up there. RL. And that is the form that's given in the answers, I think. Yes, it is. Well, that's how it's arrived at. But as with the next thing you do is you back substitute IC somewhere way back up stuff I've rubbed out to get a value for I1, and then having obtained that, you can work out what VL is by just applying some circuit law. You can say VS minus VB plus VR1 leaves you with what VL is, and VS minus VL is VC, or you can, any other way you want to do it is fine.